So I get that written down, and then I think, okay, wait a minute. I've got to find the value of this integral. I don't like integrating backwards, so I'm going to just rewrite this as -6 minus the integral from -3 to 0 of f of t dt. Any questions there? So again, I'm not guessing, I'm not brainstorming, I'm just thinking, just line by line. I'm not stuck, I'm still moving. So a flashcard you need to have is, if you switch the limits on an integral, the value of the integral is still the same as long as you multiply that integral by -1. Because I switched the limits, I've got to multiply by -1. Carlos versus John, please.
Why don't you integrate backwards?
Personal preference, to be honest.
So, but will it be the same answer?
If you integrate going forward graphically, area above the axis counts positive, area below counts negative. If you integrate backwards graphically, they just switch. So you can do that as well. It comes out exactly the same result. So it doesn't really matter. If I'm doing it on a calculator comparison, I don't even worry about it. I just plug it in. If I were doing it with the antiderivative method, I probably wouldn't worry about it either. I don't know, it's kind of personal preference. You don't have to.
Okay. Okay.
Two pebbles. Anybody else? So here we go. So let's see, this is -6 minus. To find this integral, I come over to my graph of f. I start at -3. I'm going to 0. So I'm finding this area right here. Anyone have a question about what area I'm finding? Cool. So let's see. Parentheses with the subtraction. Good to put a parenthesis. That's a quarter circle. So that's pi. Take the radius of the circle, which is 3. Square that radius. Divide by 4. Close parenthesis. I'm done. That's g of -3. It says g of -3 is equal to this. So it's equal to this. I found the value. There's nothing else to do. Just stop there. So to find the value of an integral, I start at -3. I go to 0. I'm integrating out. I'm finding this area. It's a circle. Circle is pi times radius of the circle squared. It's a quarter circle, so it's a fourth of it. Question. Okay, again, back to Aaron's comment. What I was trying to explain is, as I work a problem, this worked just fine. I didn't have any guesses, I didn't have any brainstorming, I just worked the problem. But I didn't make the mistake of thinking that I have to understand all of the steps before I do the problem. Again, we're not trying to remember how to do problems, we're trying to remember concepts and apply them to new problems. Just do one line at a time and then you're done. Just stop.
So if you didn't switch the negative to 0, would it have been pi 0 squared over 1?
No, this is the radius.
Oh.
Radius. The radius of the circle is 3 regardless.
Okay.
Good question. You're okay. Anybody else? 2 pebbles for Ethan. Okay, keep going. Another big test taking strategy. Come on, eyes on the board. Look. When you see a period stop, a lot of students make the mistake of reading everything and trying to do everything kind of simultaneously. Bad idea. Just do that much and stop. I've done that, now I read some more. Find g prime of x. Stop, it said to do something. So just do what it says. G prime of x. Well, this is g of x. I know how to take derivatives. So let's see, g prime of x would equal, the derivative of 2x is just 2. To find the derivative of an integral, I identify the integrand, I plug in the upper limit, multiply by derivative of the upper limit. Let's say I'm taking the derivative of g of x, so this is dx, minus, same thing with the lower limit, and we want to talk about that. That's memorized fact. That's straight off your flashcard. So again, key right now on April 10th is your number one priority has got to be getting your flashcards memorized, because you're working problems. You're not losing points because of memory. Like if you lose points because you can't figure it out, that's okay. If you get all your memory solid, you'll score much better. Please, Dawson.
Can you just go over when you like make it b over x or b over d or after that?
Alex, I'll give you 5 pebbles for that. Seriously. Outstanding question. You just have to pay attention to what you are taking the derivative of. So because we're taking the derivative of g, and the input variable is an x, then it becomes dx. So for our class, it's very simple. We always take the derivative in terms of input variable. So the input variable is an x because we're differentiating g of x. The t over here is just needed to kind of represent the integral. Does that help?
Yeah, so use y, so you went f of x just because same thing.
So that's the rule. Well, that's different. So the rule is when I'm taking this derivative, I find the integrand, and I find the variable of the integrand, which is a t, and then I plug in the upper limit. So that x was a different reason. Does that make sense?
Yes.
Good point. Pretty out. Keep going. Cleaning that up, g prime would be 2 plus f. And that's the second point. So if you have that written on your paper, you now have 2 points. 4 questions. And again, oh sorry, Nick, go ahead.
So my first question is, do you end up finishing on paper with like flashcard suggestions?
Oh, not yet. Sorry, the family project ended up consuming a funeral and some other things. So anyway, go ahead.
And then, so
Still on my list though.
So f of x and f of t are interchangeable kind of, because it's like the graph of f, but it kind of tripped me up. I just treated them as the same thing.
Yeah, really, I'll give you 5 pebbles for that. Look at me, everybody, eyes up here, come on, everybody. The discussion day is really good. It's exactly what you want to do is want to grade the FRQ, but we also want to learn as we go. Because I'll remind you again, you're not going to succeed by memorizing problems. You succeed by memorizing concepts, making sense of them. Because you don't have any idea what they will give you as a test question. So every time I give you a practice test, it's a brand new question, you just have to learn how to apply your knowledge to the question. Okay, look here. The way the integral works is really the variable is x. T really isn't a variable at all in the following sentence. If I'm going from, say, 0 to 1, that means that this t value is going to be every single value from 0 to 1. So it's really all in terms of x. The t is just a placeholder. It's saying, hey, if you're doing the integral on your calculator, you plug in 0, and you plug in 0.1, 0.2, 0.3, 0.4, 0.5, all the way to whatever x is. Does that help a little?
That's because the top one is x.
Right. So they're saying, you know, normally we think of an integral as like being from 0 to 1, or 0 to 2, or 0 to 3, or whatever. They're just making it flexible. You integrate from wherever you want to integrate. But the t really isn't unknown at all. T is every value between here and here. Because when you integrate, you plug in every single value, multiply, then add them up. Does that help a little?
Yeah.
So the FRQ is kind of looking at the graph before it represents from 0 to x. Like looking at the graph of the graph.
It's saying, where do you want to integrate this graph? You want to integrate this graph from here to here? That's what we just did. So that's what we're doing.
So it would be 0 to 2.
These are values of x. They really are.
Wouldn't it like make sense though, just to write the 0 to 2 would not be
Here's the problem.
full, or would that not work?
No, here's the problem. Hey, everybody, eyes on the board. Come on, everybody. You will never see an integral in this class where this variable and this variable match. Because it doesn't make any sense. This is a fixed number, like 3, negative 3.
So that's independent variable unless it's dependent.
This is not, no, this is a variable. This is known. I know exactly what t is. Like, look at this integral right here. -3 to 0. Okay, if we were doing that on a calculator, what you would do, you would plug in -3, then you plug in -2.9, -2.8, -2.7. I know every value of t.
Oh, okay.
They're just the numbers in between. So t isn't unknown at all. X is what I specify. So x is the variable I'm plugging in. So it's really the independent variable. G of x is the dependent variable.
So the graph of F is like.
It's really a graph of f of x.
It's F of X anyway.
This is f of x. This doesn't have to say t. This could say u or z or w or q or anything. It's just a temporary placeholder. These variables never match, ever, in our class. Or I can't think of any application. Anybody else?
That's like the X symmetry. Well, not in that case.
No, x is the variable. In this problem, it's back to Dawson. X is the variable. T has nothing to do with the problem at all. It's just a way, I can't put an x there because it mathematically makes no sense. Because if I put an x here, when you plug in -3, you're going to want to put a -3 there. That's not what we want. We want to integrate from 0 to -3. So we have to have some other variable. It could be, think of it as f of z. It's not time. It's just a temporary variable. All right, let's keep moving. Anybody else? So good questions. You're on the right page. So I've got to find g prime of, all right, keep going. Evaluate g prime of -3. So then I just do that. So g prime of -3 is going to equal 2 plus f of -3. Really, for our class, just kind of summarizing Aaron's questions, you don't have to just don't let this bother you. The variables will never be the same, and they're not saying time and x at all. This is really like f of z. And z is just this, you just can't have them be the same, or it doesn't make sense.
I see how that makes sense. I was just thinking like you were to look at the graph of that and then you would say f of x when x equals 1 is the same as f of x equals 1.
It is.
But just using that in a different context, because you can't have integrating from 0 to x and x. That's not the way we're going from 0 to 1 variable or integrating from that one variable or that one tiny little.
There you go. Okay. 2 is the second point. G of -3 is just 2. Question?
Negative?
Positive?
Okay.
Don't worry, I may have said negatives. Next one, part B. It says determine the x-coordinate of the point at which G, okay, looking for an x-coordinate where G has an absolute max on that interval. Justify my answer. So I'm looking for the max of G. Okay, right there I get a flashcard memory that comes straight to mind because I have my flashcards so thoroughly memorized. I don't have to ponder it, it just comes to memory right away. Let's see, max of G is at beginning, that's -4, and that's x equal 3, or where G has a critical point. That's the min-max theorem. That one needs to be memorized. Question. And the memory should just pop to mind right away, because as you read the problem, it says find the max of G. Sit down, please.
So we can't just say where g prime of x chooses the positive and negative?
That's just a relative max. So you can't confuse relative with absolute or you will lose points. Double. Anybody else? So then I say, okay, G has a critical point. Where G prime equals 0 or G prime is undefined. Questions so far?
So isn't that the first point?
Hey, nicely done. 2 pebbles for Ethan. I just got the first point. Okay? By simply remembering the min-max theorem, I earned a point. So, again, modeling how to solve the problem. Just Aaron and I talked about this earlier today, so I keep referencing Aaron. But I haven't had to brainstorm anything. It's just coming straight out of my memory. But I also haven't tried to solve the problem straight from memory because I've never solved this problem. So I'm just doing one thing at a time.
Okay, so when I was doing this problem, like, I knew that, but, where does it say that you need to have it to write that?
That just has to come from your memory. It doesn't say that. It says right here, determine the x-coordinate of the point at which G has an absolute max. So I stopped right there and I said, hey, wait a minute. The way I always find where something has an absolute max is via this theorem.
Yeah, but,
Keep going.
like, I thought that in my head, but where does it, like, how did you know that you would have to write that to get it?
Oh, I got you. So that's just from practicing the test. Like by doing enough min-max problems from the AP test, I know that I need to write this stuff down.
Oh.
Yeah, that's a good question. No 2 pebbles for that, parents. It really is just knowing from doing enough tests that when they say find the absolute max, and they say justified pairs, then I've got to write it down.
Okay.
Now, you don't have to write the green. I wrote that as I was explaining to hopefully make it easier for you to understand. You do need to write the blue.
Okay.
So, you have to write it just because that's what it says, or because it says justified?
Because it says justified.
So if it didn't say that, would you have had to write it?
I would not have, but I've never seen one where they don't say justified. Whenever they say find the absolute max, I can never recall them not asking you to explain or justify that sort of thing.
Well, at this point, G of X is equal to the graph on that.
No, so close, Peyton. What we found back here on part A was that G prime is 2 plus F. So I'm going to use that. That's exactly my next thought. So G prime is equal to 2 plus F. And I'm trying to figure out when that equals 0. Well, solving an equation, flashcard memory, means find the value that makes the equation true. So I need to find the value of x which will make this true, which means I need the value of f to be -2. Well, solving an equation means find the value that makes the equation true. Blake, please.
Okay, so for the point for the G prime of x equals 0, does it also need to be like G prime of 0, G prime of x is 0 at, and then say the point it is to get that point, or you just say G prime of x?
That's going to show up right here.
Okay.
So by just saying that I need to figure out this, they did give me the 1 point. Now once I figure out at what x is G prime equal to 0, they'll give me the second point.
Okay.
Is that your question?
Yeah.
2 pebbles? Going? I'll show you in a second. Oh, I can answer that, I'm sorry. The max of G always occurs either at the beginning point, the ending point, or at an interior point, something inside. That's what they mean by interior point. We haven't found it yet, but that's what they mean by interior.
So those interior points would be like physical points.
Right, that's it. That's all it is. That's perfect. The min-max theorem says, you can say it another way, Aaron. The min-max theorem says the max of G will occur either at the end points or at interior critical points. The max can't occur anywhere else. Did I answer your question?
Yes.
Cool. 2 pebbles. Anybody else? Keep rolling here. So I look at the graph of f, and I say, I gotta see where f is equal to -2. So that's here. Right there. That's where f is equal to -2. Question. So I need to find that x. I just do it, honestly, 8th grade style. I just count. This is a straight linear line. So let's see, it starts up here at 0, 3, ends down here at, so it's dropping 6, slope of this thing, it's dropping 6, well, it's going over 3. So this point is up 3, right?
Yeah, down
Oh, I'm going to here.
here. Yeah.
So then that goes down 3 more? Yeah, I'll get to there in a second. Don't worry.
Oh, okay. I
You're
thought you
okay.
was going to-
Yeah, you're okay. 'Cause what I had to do is I have to go from 2 known points to start
Oh,
with.
okay, yeah.
So I can see the slope is -2. Yeah, you're okay. Everybody good there? That was pretty good. So now I do what you're thinking. I count it. I say from here to here is down 5. And it's over then half as much. So that means, let's see, this point would be over half of 5, which is 5 half. You could, either way. Either way. I just like counting, but that works just as good. I just count it. So the point has got to be 5 over 2. Question. So, G prime of 5 over 2 is equal to 0. There, I got my second point now. Questions? Okay. Now I've got to figure out, look, I've either got to, I got to go find like G of -4, G of 3, and G of this, find where G is highest, or I can take advantage of a easier method. The graph of G is really the graph of G prime is really the graph of F just shifted up 2. Okay, eyes on me, everybody, eyes here, look. To me, this is a really good example of where I can get 2 out of 3 points pretty quickly. It didn't take a whole lot of math to get 2 out of 3 points. The third point to me is much harder. So if you get stuck at this point, don't worry about it. Just move on. You don't have to get the problem finished to get points. You get as many as you get. So if you're feeling stuck, just move on. But at this juncture, I could go and use integrals to find values of G. Or I can just say, hey, the graph of G prime is really this same graph shifted upward 2. Which means it's like saying the x-axis is down 2. So this is my x-axis if it's the graph of G, right here. Questions to there. Which means I can just write down from here all the way to here, G prime is positive. So I'm going to write that. So we'll say for starting at -4, all the way to 5 halves, G prime of x is positive. So G is increasing. Then I write for 5 halves until 3, G prime is negative, so G is decreasing. Please.
Oh yeah. So if G prime of x equals f of x minus 2, then what it should down to?
Mm-hmm.
So it never has to do with the x-axis.
Not if you're just adding a number.
Okay.
Yeah, it's because f of x really means the y coordinate.
Mm-hmm.
And you're saying the G prime function is simply the
Oh,
f
yeah,
y
yeah.
coordinates plus or, yeah, you got it, you covered it. So therefore, G of x is greatest at x equal 5 halves. And I'm done. That's the third point. Okay, again, my advice is this. You should be able to remember this. That's just straight memory. It's just straight memory. I'm trying to find the max of G, therefore I've got to identify the endpoints and critical points of G. You have to have straight from your flashcards how to find the critical point of G. To me, the first 2 points are easily accessible. The third one, yeah, whether you think to do this whole shift thing or not, I don't know. That's a little trickier. Okay, so if you're struggling with the third point, don't stress at this juncture. The first 2 are where you should be focused. Other questions? Please.
Could you just say in a nutshell how you know that it's separated to the factors?
So it says right here, G prime is the F graph moved up 2 spaces. But moving the graph up 2 is no different than moving the axis down 2. That's all. Is that your question? 2 pebbles, anybody else? Okay, next one. Okay, C says find all values of x on intervals in which the graph of G has a point of inflection. Stop. Give a reason. Okay. So I just remember, let's see. G has a point of inflection. This is Gannig's chart. G has a point of inflection when G changes concavity. That happens when this changes increase to decrease or vice versa, or G double prime would change positive to negative. I have a graph of G prime, I'm just going to use that. And right, G prime changes, increase, you can abbreviate, to decrease at x equals 0. So G has inflection point at x equals 0. And that gives me a point. Follow-up question. Please, Nick.
So, whenever there's like a shift in a graph like that, is it just always going to be on the y, not on the x?
Cannot say that. This shifting is not a common thing that they've done over the years.
Okay.
I don't recall if they ever shifted by the x or not. Yeah. The x shift is harder to remember. The y shift is easier because it's just up down. Anybody else? 2 for Nathan. Awesome. Okay, so we're done with that. Hey, this is a good example. Look, focus. Come on. In part C, there was a pretty easy point available. So you don't want to get bogged down. Just keep moving. Get points where you can get them. Don't let yourself get stuck reading, thinking, and thinking. Think of something, write it down, keep moving.
So when we go to that point, we would think it's like, I don't know, if you do on that last part.
Just keep going. Yeah. Yeah, for sure. Like, I think it's realistic to say, hey, you can have memorized that the max of a function is this. That's just a memorized fact, okay? You can have memorized how to find a critical point. So I think getting to here is realistic. Thinking about what to do then, I could see being troublesome. And so I could see you kind of wondering, what do I do next? Do I do this? Do I do that? That's when it's good to move on. So. Part D. Find the average rate of change of F on this interval. There's a period right there. You should stop. You shouldn't read anything more. If you keep reading, you're going to get confused. So just stop and do what it asks. Average rate of change means secant slope. Memorized fact. Average rate of change means secant slope. So it's supposed to find the secant slope of F. Okay, notice how slow I work. Another thing that costs people points is you work too fast. The AP test is not a race. It's testing, can you think logically one little thing at a time. So I need to find the average rate of change of F from here to here. So I'm not using G anymore, I'm using F now. So let's see, we want to go from -4 to 3. I'm finding this secant slope right here. So that's just that. You could have written, let's see, so F of 3 is -3 minus 1 all over 3 subtract negative 4. To get the point, you've either got to have this in red or this in red. That's what you have to have to get the point, one of those two. This box or this box. That would give you this point, average rate of change. Question? Now I keep reading. There is no point C between here and here, so there's no x-coordinate, where the tangent slope of f is the same as this. You can see it visually. As you follow this curve, watch my pen. My pen can represent the tangent slope. Nowhere along this curve is the slope of my pen the same as this line. Okay, that's the mean value theorem. The mean value theorem says that from here to here, we would expect to find one tangent with the same slope as the secant. But it's only true if the function f is both continuous and differentiable. F is continuous, but due to the vertical tangent in the corner, f is not differentiable. So you get an extra point if you can remember the mean value theorem and write something very much like that. That's the second point.
Because I forgot, talking about the x equals 0, where that's the point, not differential. I know that it's not differential. Is it just because there's not like a hole in it?
No hole, no vertical asymptote.